Now, talking more about positive and negative work, I want to take an everyday object. Talk about an elevator. Okay, so we have an elevator, and it's starting on the 30th floor. Okay, here's us, woo, walking over the elevator. Okay, and we're going to take it all the way down to the bottom. I'm going to talk about negative and positive work. Okay, so as I get in the elevator, there's forces that are acting on that elevator. I'm going to simplify it. We're going to say that on this elevator we have the force of gravity and we have the force of tension. Okay, the cable and the weight. Cool? Now, the elevator is going to move down, so it's going to experience a change in its displacement down. Okay? So, looking at the work that's being done on the elevator. So, talking about the work that's being done on the elevator, I can say that the work done by tension is going to be equal to the force of tension times the change in its displacement. I'm just going to use... Okay. And I can say the work done by gravity, or the force of gravity, I should say, is going to be equal to the weight times the change in the distance. That's not going to change the entire time. Okay? So, we get in the elevator and we want the elevator to go down. If you were building the elevator, what would you do in order to make that elevator go down? Okay, you've got a cable and you've got the weight of the elevator. Those are the only forces acting on it. We don't have any other motors, anything like that. Okay, so how would you make that elevator go down? Well, we can either increase the weight inside the elevator so that the weight of this elevator is going to be larger than this, or we can decrease the tension. Well, most elevator designers don't have a way in which they can just increase the mass of an elevator by just pressing a button. But we do have ways in which we can decrease the tension by pressing a button. So in order for that elevator to drop, what we're going to do is we're going to decrease the tension. So we have a small tension. So at this point right here, we have, here's the work done at small tension with my big displacement, and my weight is going to stay the same. So that means that the work done by the tension is going to be smaller, and this one's going to remain the same. Okay? So if when I got in the elevator wasn't moving, it was stationary, meaning that all the forces on that object, because it's not experiencing a change in its motion, all the forces on that object were equal to each other, that this original T is equal to the weight of the object, and then I hit the button inside the elevator so that the T got smaller. That means that the work done by tension should be less than the work done by the weight, by the force of gravity. So that means that this term is going to do more work than this term. Okay? Now, is tension a positive or a negative work in this case? Is gravity a positive or negative work? Well, if we look at it, tension is a vertical, or points straight up. And the displacement is straight down. So, because they're opposed to each other, because they're in the opposite direction, that means that tension is going to do negative work. Okay? Now, what about gravity? Well, gravity is going to be bigger than tension, and it's going to be down, and here's my displacement. So is that positive or negative work? Well, because they're both pointing in the same direction, it's going to be positive work. So that means if I were to add this term to that term, and when I add a negative to a positive, it's subtracting them. So I'm going to take this amount out of this. Okay, I'm going to have a positive number. Now, the net positive work done on an object means that the object is going to be speeding up. Okay, so when we talk about positive work, we're talking about an attempt to speed the object up. Cool? So net positive work means an attempt to speed the object up. Or not net positive. Take that back. Positive work is an attempt to speed the object up. Negative work is an attempt to slow the object down. Okay? Net positive work, net meaning that I totaled all my work together and I got a positive number, means that the object is speeding up. Net negative work, when I totaled all my forces or all my work together and I got a negative number, means that the object is slowing down. Okay? So because it's a net positive work, that means the object is going to be speeding up. Well, as we're going from the 30th floor to the bottom floor, we probably do not want to be speeding up as we fall 30 floors. Okay? So what most elevators do is they go to a point, they speed up for a little while, not very much, depending on the size of the building, and then they get to a point where they're traveling at a constant speed. Okay? So you get to a point where you're traveling at a constant speed. Now, at a constant speed, I'm neither speeding up or slowing down, right? So what do you think that means for my tension and my force of gravity? So I'm talking about this point in the middle. We're traveling at a constant speed. So what do you think that means for the force of tension and the force of gravity? Well, it turns out that the magnitude of tension and the magnitude of gravity are going to have to equal each other. Okay? And why is that so? Well, the reason is that each object experiences a displacement. They experience the exact same displacement. Okay? They both experience the exact same displacement. Tension is still doing negative work because the displacement is still down. So tension is still going to be in the opposite direction of it. Okay? So tension being up and the displacement being down, meaning that it's doing negative work. So it's attempting to slow the elevator down. Gravity is still going to be down the same direction as the displacement, so it's attempting to speed the object up. But because it's moving at a constant speed, a constant velocity, well, a constant speed, at least, a constant speed, that means that the amount of attempt to slow the object up and the amount of attempt to speed the object, or slow the object down and to speed the object up, they're equal to each other. Neither one is dominating the system. So the exact same amount of effort to speed the object up is going to be countered by the exact amount of effort to speed the object or to slow the object down. Okay? So this amount of work has to equal this amount of work. And because they're experiencing the exact same displacement, they must be experiencing the exact same force, the same magnitude of force, just in opposite directions. Okay? So right there is I'm moving at a constant velocity. So I sped up when I got in the elevator. I need to move down. It's stationary, so I got to speed it up. So I'm moving it down. So I'm experiencing a positive amount of work here to speed the object up, and then I'm moving at a constant velocity at this point as I'm traveling probably from the 29th or the 28th floor all the way down to the 2nd or the 3rd floor. Okay, I've sped the object up for a couple of floors. Then I'm moving at a constant velocity, meaning that both of these are doing the exact same amount of work. There's the exact same amount of effort to slow the object down as it is to speed the object up for those couple of floors. And now we get to the bottom. Okay, now hopefully you don't want the object to continue to travel at a constant velocity when it hits the bottom. That's not a good thing. Okay, hopefully you don't want the object to speed up as it hits the bottom. Okay, that would also not be a good thing, not unless you really didn't care for the person in the elevator. So you want to slow the object down. So that means what? That means what kind of work do I have to do at that point? Do I need to do positive work or negative work? Well, I have to do negative work. I have to exert an effort, more effort to slow the object down than to speed the object up. So talking about this system again with tension and gravity, well, I have two forces that are acting on this elevator. I have the weight of the elevator and the tension of the elevator. Which one do I have to increase? Or decrease, I guess. Well, tension. Hopefully when you get to the bottom of the elevator, you're not losing weight. Okay? You're not throwing people out of the elevator as you're falling to slow it down, to lose weight. So the other way to doing that is to increase the tension. So I can either decrease the weight of the elevator by pressing a button, which is very, very uncommon. I guess you can have the elevator doors on the bottom open up and everyone fall out and slow down the elevator, but it kind of defeat the purpose of having an elevator. Or I can increase the tension. So as I get near the bottom, that means my tension will have to increase. Big tension, same displacement. Where gravity, the weight of the elevator, doesn't change. Okay? So in this case, the tension has to do more work than the weight. Okay, it has to grow in size. Because this is the negative component of the work that's being done on the elevator. The more negative it is, the more it wants to slow that object down. Okay? So, negative work means that it's an attempt to slow the object down. Positive work is an attempt to speed the object up. When I'm talking about speeding the object up, I'm using the word speeding because I'm talking about speed. I'm not talking about velocity. Velocity turns out to be not all that important. And we'll talk about that when we talk about energy. Okay, so this is an attempt to speed the object, or to slow the object down. Negative work slows objects. Positive work speeds objects up, or attempts to. It's only when we deal with the net on that the object will speed up or slow down. So if the net work is negative, that means there's more effort to stop the object or to slow the object down than there is to speed the object up. Okay? So that's the difference between net or positive and negative work.